Hello everyone. Today we are going to discuss about the gravitation chapter, and it is for only short term purpose. Now see this one, 2015 Neet problem. It is a remote sensing satellite of Earth revolves in a circular orbit at a height of 0.25 into 10 to the power of 6 meter. While you are reading the problem, he given in the third step it is the height. So h is equal to the given. I am writing here only. This is height. H is equal to 0.25 into 10 to the power of 6 meters above the surface of the earth. If the earth's radius is, so earth radius r is equal to 6.38 into 10 to the power of 6 meter and g is equal to 9.8 meter per second square, then orbital speed of the satellite is, we have to calculate what is the orbital speed. Okay, before solving this problem, I want to derive the what is orbital speed derivation. Okay, what is orbital speed? A horizontal speed it is required to the satellite to revolve in a particular orbit around the planet is called orbital speed. A horizontal speed is required to the satellite to revolve in a particular orbit around the planet is called orbital speed. So we have to derive this equation. First I am taking one planet. This is one planet P. Planet name it is the P. Now mass of the planet is capital M. Mass of the planet is capital M and radius of the planet is R. Just I am writing mass of the planet. Mass of planet I am writing as a M. P is equal to M. Mass of the planet is M. Radius of the planet Rp is equal to capital R. Radius of the planet Rp is equal to capital R. Okay, fine. One satellite. This is satellite. It is revolving around the planet. It is revolving around the planet. Mass of the satellite ms. Mass of the satellite ms is equal to small m. It is above the surface of the planet is h. It is above the surface of the planet is h, isn't it? So what about the total distance? It is from center of the planet to surface of the planet is distance is r. From here to here distance is h. What about total distance is r plus h. So we can write here total distance is r plus h. Okay, fine. While it is revolving around the planet, centripetal force is necessary. So what is the centripetal force? Centripetal force formula it is Fc is equal to mv square divided by r plus h. Centripetal force I am writing as F. Centripetal force is equal to mv square divided by r formula, but here the distance it is r plus h. So that's why I have written Fc is equal to mv square divided by r plus h. Here velocity, with what velocity it is moving? With a orbital velocity v0, vo, just v0 I am writing. This is nothing but a v0 is the orbital velocity. While it is, how this it is moving along in a circular path around the planet. Okay, centripetal force is required. The centripetal force is balanced by the gravitational force. Centripetal force is balanced by the gravitational force. So gravitational force Fg is equal to, what is the gravitational force formula? G, capital G into mass of the planet, mass of the satellite divided by total distance is r plus h into whole square. Gravitational formula, actually I am writing here centripetal force Fc is equal to mv square by r, and gravitational force formula it is capital G into capital M small m divided by r square. Just I am writing, this is centripetal force formula. The centripetal force formula I have written like this, and gravitational force formula I have written like this. This is equation number 1 and it is equation number 2. I told you very clearly, when satellite is revolving around the planet, centripetal force, because of the centripetal force only it is revolving around the planet. The centripetal force is balanced by the gravitational force. So the centripetal force is balanced by the gravitational force. For that purpose I am writing equation 1 is equal to equation 2. Equation 1 is equal to equation 2. Okay. M V naught square divided by R plus H is equal to capital G, capital M, small m divided by R plus H whole square. Here both side mass of the satellite get cancelled, and also R plus H here whole square it is 1 R plus H it get cancelled. So what are the remaining here? V naught square, I am writing it as V naught square here remaining, and this side it is capital G, capital M divided by R plus H. This is the remaining. So this one I am writing as a V naught is equal to under root of capital G M capital M divided by R plus H. This is the equation, one equation. And further, if I want to calculate this equation, we know it is what is the gravity on the surface of the earth. Gravity on the surface of the earth formula. Gravity on the surface of the earth, just equation number 3. Gravity on surface on the earth. Gravity on the surface of the earth. Gravity on the surface of the earth, G is equal to capital G M divided by R square. Okay, but I want to derive this equation, then after I will tell you. For example, see this one. This is earth. Mass of the earth it is capital M, and a small object is placed on the surface of the earth. This is earth. Mass of the earth it is capital M, and a small object is placed on the surface of the object. So the mass of the object it is small m. From here to here distance is, I am taking center of the earth to center of the object. It is distance is I am writing as a R, isn't it? What is the gravitational force? Is the attractional force. According to the gravitational force I am writing F is equal to capital G into capital M, mass of the earth into mass of the object divided by distance. From here to here distance is R. So that is R square. This F is equal to I am writing as a weight of the object M into G. Here small m is nothing but a mass of the object. Capital G into capital M small m divided by R square. Here mass get cancelled. Small g is equal to capital G M divided by R square. So gravity on the surface of the earth, small g is equal to Gm divided by R square. Gravity on the surface of the earth. Now according to this equation I can write small Gm is equal to, so Gm is equal to Gr square. This R square I am taking left hand side, so Gm is equal to Gr square. It is equation number 4. Substitute equation number 4 in equation number 3 here. Equation number 4 in equation number 3, if I substitute it, V naught is equal to capital G. Capital Gm is equal to what we have, it is Gr square. Capital Gm is equal to Gr square divided by R plus H. For example, R it is very greater than H. If R it is radius of the earth, it is more than very greater than the height of the object from the surface of the earth, at that moment H is negligible. So V naught is equal to, you can write as a G R square divided by R. Here H is negligible, so R square and R get cancelled, means V naught is equal to under root of G into R. V naught is equal to under root into G into R. This G value, V naught is equal to, G value is nothing but a 9.8 meter per second. Radius of the earth, it is the 6.4 into 10 to the power of 6 6.4 into 10 to the power of 6. If you substitute and calculate, we can get it is the 7.7 kilometer per second. We can get it is 7.7 kilometer per second. So orbital speed is equal to, orbital speed of the satellite is nothing but a 7.76 kilometer per second. This is about the orbital speed. Once again I want to explain, then I will complete the problem. First, how I explain the orbital speed means, once again observe the step by step. Mass of the planet is capital M, radius of the planet is capital R, and mass of the satellite is small m. See here, this is the planet. This is the planet. Mass of the planet is capital M and radius of the planet is R, and a satellite is revolving around the planet. Mass of this satellite is nothing but a small m. This satellite is above the surface of the planet, is height is the h. While it is revolving around the planet, centripetal force it is acting. What is centripetal force means? A force acting which is towards the center of the that is nothing but a centripetal force. So centripetal force Fc is equal to, we have formula mv square divided by r. Here r is nothing but a distance. From here to the distance is the r plus h. That is equation number 1. Now this centripetal force is balanced by the gravitational force. So gravitational force formula Fg is equal to g into capital M small m divided by r square. Here r is equal to r plus h. So instead of the r I have written r plus h whole square. Capital M is the mass of the satellite, small m is the capital M is the mass of the planet, small m is the mass of the satellite. And I told you centripetal force is balanced by the gravitational force. That's why equation 1 is equal to equation 2. Here mass of the satellite get cancelled. Here square and r plus h get cancelled. Remaining terms I have written b0 square is equal to gm divided by r plus h. b0 is equal to under root of gm divided by r plus h. That is equation number 3. Then gravity on the surface of the earth. Gravity on the surface of the earth, how to calculate? Gravity on the surface of the earth means I am taking, this is the earth. Mass of the earth it is capital M. Radius of the earth it is capital R. Now a small object means this marker only I placed on the earth surface. At that time mass of the marker it is small m. Now from center of the marker to, if I place like this, center of the marker to center of the earth, distance is the r. That is nothing but a radius. So r I take. So gravitational force F is equal to capital G, capital M, small m divided by r square. Here F is equal to weight of the object, mg. Small m get cancelled. G is equal to gm by r square. I got it. This r square if I taken this side, gm is equal to gr square. This is equation number 4. This gravity on the surface of earth. From here to we can get equation number 4. Equation 4 I substituted in equation 3. Gm is equal to, see here, Gm is equal to gr square is there. I substituted, I got like that. If r is very greater than h, if r is very greater than h, at that moment h is negligible. This h is negligible. So that's why I have written here gr square divided by r get cancelled. b0 is equal to under root of gr. b0 is equal to under root of gr. G value and radius of the earth if I substitute, b0 is equal to, we got 7.76 km per second. This is orbital velocity. Next, we have to solve this problem. Orbital velocity, we have two equations. Orbital velocity, we have two equations. One formula it is in terms of the height, and one formula it is in terms of the radius. See here, this is in terms of the height and this is in terms of the radius. Here in this equation height is not there. So, but in 2015 Neet question, they given height and radius they given. So what we have to solve it? We can solve this equation, we can solve this one by using of the equation number 3, not this equation. We can solve this question by using of the equation number 3. Next, see this one. He given height h is equal to 0.25 into 10 to the power of 6 meters and radius r is equal to 6.38 into 10 to the power of 6 meter. So in this situation, B naught is equal to under root of Gm divided by R plus H. B naught is equal to Gr. This B naught equation 7.92 kilometer per second. Okay. I am taking equation number 3. B naught is equal to under root of capital G M divided by R plus H. But here we don't know what is the M value. G value we know it. It is constant only. So what? But we don't know capital G M value. This one we can write as a, in previous explanation there I have written capital G M is equal to small gr square. This equation if I substitute in this one, gr square divided by r plus h. In this one we have to solve small g value. He given it is 9.8. Small g is 9.8 and radius r is equal to 6.38 into 10 to the power of 6 whole square. Here square is it and whole divided by r 6.38 into 10 to the power of 6 plus h equation 0.25 into 10 to the power of 6. Then if you solve this one we can get it is 7.76 kilometer per second. If you solve this one we can get 7.76 kilometer per second. It is 2015 problem. 2015 Neet question. Okay. Okay. Now we can discuss 2016 problem. 2016. Okay. The ratio of escape velocity at Earth V to the escape velocity at the planet whose radius and mean densities are twice as that of Earth is. If you see this problem, we have to discuss about the escape velocity. We need to derive the escape velocity derivation. Then I will solve this problem. How we can solve this problem very easily, I will explain. First one, escape velocity. What is escape velocity? A minimum velocity is required to the object to escape from the gravitational force, that is called escape velocity. For your understanding, a minimum velocity required to the gravitational force, gravitational field it is. This is the Earth. This surrounding is nothing but a gravitational field of the Earth. One object is, this is one object is projected upward direction with a velocity v. One object is projected with a velocity v. This total it is nothing but a gravitational field. If you projected one object with certain velocity, at that moment, if it is escape from the gravitational field, if it is coming out of from the gravitational field, that velocity is called, we are calling it is the escape velocity. A minimum velocity is required to the object to escape from the gravitational force under the influence of the gravitational field. That is called escape velocity. Okay. Now this is mass of the Earth M and radius of the Earth it is R. Center of the Earth O. And mass of the block it is small m. If you observe this problem, if you see this diagram also, simply we can observe one object is going upward direction. When object is going upward direction, what about its kinetic energy is decreasing. If I want to simplify this one, when object is going upward direction, its velocity is decreasing. What about potential energy is increases. So here kinetic energy is converting into the potential energy. So for that purpose I am writing kinetic energy plus potential energy is equal to 0. So total energy becomes to 0 because kinetic energy is imported to the potential energy. Kinetic energy is converting into the potential energy. At that moment, total energy will becomes to the 0. So kinetic energy plus potential energy is equal to 0. What is kinetic energy equation? Of into small m into v square. Potential energy equation we know very well, minus g into capital M small m divided by r, that is equal to 0. It is the potential energy equation and this is kinetic energy equation. And this potential energy, if I taken that set, half into mv square is equal to capital G capital M small m divided by r. Here small m get cancelled. What is the small m? Mass of the object. What is capital M? Mass of the earth. And r is nothing but a radius of the earth. 2 I am taking the set. V square is equal to 2 g m divided by r. This is escape velocity. For this purpose, escape velocity I am writing as a, this is VE. Okay. Now square if I taken this set, VE is equal to under root of 2 gm divided by r. This is escape velocity equation. I am writing it in the box. Next one, if I simplify this equation, we already derived what is the gravity on the surface of earth. Gravity on the surface of earth, G is equal to capital G m divided by r square. R square if I taken this side, gr square is equal to capital G m. This is gravity. Gravity on the surface of earth. Gravity on surface of earth. Now equation number 2, equation number 1, this is equation number 2. Substitute equation number 2 in equation number 1. This value I am substituting here. VE is equal to gm. I am writing as a gr square. Gr square divided by r. Here r and r square get cancelled. E is equal to under root of 2gr. V is equal to under root of 2gr. Here small g value we know very well. 2 into small g is equal to 9.8 meter per second and radius of earth it is 6.4 into 10 to the power of 6. R is equal to 6.4 into 10 to the power of 6. Then if we calculate this equation, we can get 11.2 kilometer per second. Escape velocity equation is nothing but escape velocity of the object. V is equal to 11.2 kilometer per second and this is escape velocity equation. Escape velocity, this is in terms of the mass and without mass. V is equal to under root of 2gr and V is equal to under root of 2gm divided by r. Now our problem, before going to this one, once again I will explain this one. See here, one object, mass of the earth is capital M, radius of the earth is capital R. Center of the earth to surface of the earth it is nothing but a radius, that is the r. One object placed on the surface of the earth, that is mass it is small m. Now this object is projected upward direction with a velocity v. While it is going upward direction, kinetic energy gradually decreases, potential energy increases. Means kinetic energy and potential energy both are equal and opposite direction. So at that moment total energy it becomes to 0. That's why I written kinetic energy plus potential energy is equal to 0. Kinetic energy equation of mv square, potential energy in the gravitation problem minus g mm small m divided by r. This one I am taking right hand side, I got this in. Small m get cancelled. What is small m here? Mass of the object. Small m get cancelled. B is equal to 2gm divided by r square. Square root if I take in that side, it will become as a root. Equation number 1. Now this one I want to simplify more, means gm is equal to, we know it is gr square. gravity on the surface of the earth. Equation 2 substituted in equation 1. I substituted here. So r square and r get cancelled. Finally we got escape velocity v is equal to under root of tau g r, that is equation number 3. This is final one. If I substitute gravity on the surface of earth and r value radius of the earth, we can get escape velocity of the object on the surface of the earth, it is 11.2 km per second. If the object escape from the gravitational field of the earth, it must be start with a velocity is 11.2 km per second. At that time only it can escape from the gravitational field of earth. Okay, I will explain this problem now. Here velocity, we derive the equations now. Here he given in terms of the density, in terms of the radius and density. Radius, okay, first I am writing radius of the earth RE is equal to R. He given radius of the planet is twice of the earth. So radius of the planet RP is equal to 2R. It is twice he mentioned very clearly. Next also density of the earth rho E is equal to rho, and density of the planet is equal to twice of the earth. So 2 rho I have written. But we don't have it is the equation in terms of the density. We don't have it is in terms of the density. We have to convert that equation in terms of the density. How we can convert means, in this one mass is there. Mass is equal to density into volume. So here volume is shape of the earth, it is spherical shape. So volume of the sphere 4 by 3 pi r cube. I am taking this equation now. From the equation 1, first I will derive the equation. V is equal to 2g m. Small capital M is equal to density into volume 4 by 3 pi r cube whole divided by r. Here r and r cube get cancelled. We can get escape velocity v is equal to under root of 2g rho 4 by 3 pi into r square. Just I have written mass is equal to, in this one mass is equal to density into volume. Volume is nothing but a 4 by 3 pi r cube. This value is only substituted here, and r get cancelled. R square I can take from the root. R square I have taken from the root. If I take from the root, VE, actually this equation, if you observe this problem, it is related to only density and radius. So remaining all are the constant. Escape velocity V is directly proportional to R into density. R square I taken from the root, so it is R, and density rooted is there. 2g 4 by 3 pi, these all are the proportionality constant I taken. So escape velocity, this is in terms of the density equation, radius and density. Now I am writing escape velocity of the earth divided by escape velocity of the planet, that is equal to escape velocity of the earth divided by escape velocity of the planet. R E into rho E divided by R P into rho P. Now RE is equal to R and rho E is equal to rho. Just substitute here R into rho divided by RP is equal to 2R, rho P is equal to 2 rho. So 2R under root of 2 rho. See here R get cancelled, root rho get cancelled. 1 divided by 2 root 2 we got it. Answer, final answer it is 1 by 2 root 2. So option it is answer, it is 1 by 2 root 2 is the final answer. Neet question. the acceleration due to gravity at a height 1 kilometer. See here, acceleration due to gravity at height 1 kilometer and above the earth is same as a depth d below the surface of the earth. In this problem, we have to use the two equations. When object is at a height from the surface of the earth, what is the gravity? That equation we need it. And when object is at a depth d, what about the gravity? That equations. We have to equate these two equations and at that time only we can get the answer. First, I want to derive these two equations. What is the gravity at a certain height from the surface of the earth? Gravity at height h, gravity at height h from surface of earth. First I want to derive this equation. Before going to this one, we have to write. For example, this is the earth. It is earth. Now the object is at this position. From here to here distance is h. From here to here distance is the h. And from the surface of the earth to center of the earth it is capital R. What about total distance is from here to here? It is r plus h. Okay. First, when object is, this is earth, object is placed on the surface of the earth. This is earth. We know it is. What is gravity on the surface of the earth? G is equal to capital G into Gm divided capital M divided by r square. That is equation number 1. Gravity on the surface of the earth, G is equal to capital Gm divided by r square. Gravity on the surface of the earth. When block is or when object is placed on the surface of earth, gravity G is equal to Gm by r square. This equation we derived already in the previous problem. And if the object is at height h, means from here to here what is the distance is r plus h. So Gh is equal to, we can write Gm divided by r means r plus h whole square. That is equation number 2. Gravity on the surface of earth, gravity at certain height. These two equations. Now equation 2 divided by equation 1. Equation 2 divided by equation 1. At that moment, Gh divided by G is equal to, what is Gh? Capital G M divided by R plus H whole square. Whole divided by, if I do it in reverse order, I am writing R square divided by G M. Here Gm get cancelled. Gm get cancelled. We can write here R divided by R plus H whole square. R divided by R plus H whole square. Gh divided by G is equal to R divided by R plus H whole square. Now this equation I am writing like this. Gh divided by G is equal to R plus H whole divided by R to the power of minus 2. Just I am interchanging these two. R plus H I am writing numerator, R is I am writing denominator. At that time the power will become as a minus. And finally R divided by R divided by R plus H divided by R whole to the power of minus 2. Then you can write this equation. R divided by R, it is the 1 plus H by R to the power of minus 2. Now power minus 2 is there. Binomial theorem if I apply, higher order terms are first order, except first order remaining all terms are neglected. Higher order terms are if you neglected, This must simply, otherwise you have to remember every time. Binomial theorem if you are applying in our physics for your understanding, this power you have to write here. That's enough. 1 minus 2 is there. Here plus is there. Minus into plus minus 2h by r. This is gh by g. G I am taking this side. gh is equal to g into 1 minus 2h by r. Gravity at certain height. Gravity at certain height. gh is equal to g into 1 minus 2h by r. See how I derive this equation I am telling. I want to tell once again. When an object is placed on the surface of the earth, this is earth. The small object placed on the surface of earth, at that time gravity is equal to g into m capital M divided by r square. Capital G gravitational constant, capital M. It is the mass of the earth and r it is the radius of the earth. That is equation number 1. If the object is placed at certain height, that is h, from here to here distance r plus h. So from this equation gh is equal to gm, r is nothing but r plus h whole square. Equation 2. Equation 2 divided by equation 1. If I write gm get cancelled. This finally remaining terms I have written. I have interchanged these two equations. R plus h I have written numerator, r I have written denominator. At that moment power will become as a minus. See here minus. Again this step from this one I have written like this. Finally after applying of the binomial theorem, this minus will be binomial theorem formula. For your understanding I am writing 1 plus x to the power of n is equal to 1 plus nx and so on. These higher order terms are neglected. So from this one 1 plus x to the power of n is equal to 1 plus nx, means power it is here. So minus 2 I have written here. gh by g is equal to 1 minus 2h by r. Finally we got gh is equal to g into 1 minus 2h by r. Okay, this is one equation. And also everyone you can remember, sometimes we can use this equation also. This one and one more, these three equations. You can give equation number 3 and this is equation number 4. Based on the, depends upon the question, problem, sometimes we can use this one and otherwise sometimes we can use this one. Gravity at certain height. When you going above away from the surface of the earth, gravity can be decreases. The gh is equal to g into 1 minus 2h by r. Now we can calculate when object is placed at a depth d from the surface of the earth. At that time what is the gravity? Okay. Now when object is placed on the surface of the earth, we know g is equal to gm divided by r square. But while you are going depth, your mass can be changes. So that volume also can be changed. That's why I am writing in mass. I am writing as in terms of density into volume. Mass I am writing as in terms of density into volume. So volume is nothing but a 4 by 3 pi r cube. 4 by 3 pi r cube. Mass is equal to, substitute this one here, gravity on the surface of the earth, g is equal to g, mass is equal to rho 4 by 3 pi r cube divided by r square. R square and r cube get cancelled. G is equal to 4 by 3 pi I am writing. Next g rho r. It is equation number 1. Gravity on the surface of the earth, g is equal to 4 by 3 pi capital G rho r. Here rho is nothing but a density of the earth. Next one, when object is placed at a depth d, see here, this is the total radius of the earth, and now the object is placed at a depth d from the surface, depth d. Now what about the remaining portion distance is r minus d. Total distance is nothing but a r. This distance is d. What about remaining distance is r minus d. So from the equation 1 you can write here g is equal to 4 by 3 pi g r rho into, instead of the distance here we have to write r minus d. Instead of the r we have to write r minus d. R minus d. It is equation number 2. Gravity at a depth d. Gravity at a depth d. It is gravity at a depth d. Now equation 2 divided by equation 1. GD divided by G. 4 by 3 pi 4 by 3 pi G rho r minus d whole divided by G is equal to 4 by 3 pi G rho r. Here these are cancelled. We can get r minus d divided by r, remaining r. This one I am writing as a r by r minus d by r. We can get 1 minus d by r. G I am taking this side. GD is equal to G into 1 minus d by r. Gravity at a depth d. Gravity at a depth d. GD is equal to G into 1 minus d by r. Okay. Once again I will derive this equation. I will explain this equation. Then we can solve the 2017 by based on these two equations. It is equation number. I given it is 4. So this number it is 5. This number it is 6. Continuation numbers if I want to give 6, 5 and it is 7. Okay. Again I want to explain this one. G is equal to gravity on the surface of the earth. G is equal to Gm by r square, and mass I am writing as in terms of the density and volume. So mass is equal to density into volume. Here volume is equal to 4 by 3 pi r cube because it is the spherical shape. And if I substitute these values here, we can get this one. Here r square and r cube get cancelled. One r it is there. This is equation number 5. Now gravity at a depth d. Here, so from here to here distance, only this distance only. From here to here distance is the r minus d. The object at d distance, this is, and total radius is r, so remaining distance is r minus d. So the distance, this from this equation here r is equal to, I have written r minus d. It is equation number 6. So equation 6 divided by equation number 5, gd divided by g, and these two get cancelled, remaining these are. Finally r by r I have written minus d by r. R by r is nothing but a 1 minus d by r. G value, G I am taking this side. GD is equal to G into 1 minus d by r. So gravity at a depth d, this is the equation. Gravity at certain height, this is the equation. So based on these two equations we can solve 2017 problem. Based on these two equations we can solve 2017 problem. Okay. Gravity at height 1 kilometer. So h is equal to, they given it is 1 kilometer, and what is the gravity at a depth d? Here they did not mention it is the depth. So d is equal to, we have to calculate at a depth d and a height, these two are same dimensions. Here is earth, it is the 1 kilometer above the surface of earth is same as at the depth d below the surface. So both are same. So we can write from equation 7 and equation 4, GD is equal to GH. If I equate these two equations, G into 1 minus d by r, that is equal to G into 1 minus 2h by r. Here both sides GG get cancelled. 1 minus d by r is equal to 2. So 1 minus h is equal to, they given as a 1. So it is 1. Both sides 1 get cancelled. We can get it is minus d by r, that is equal to minus 2 by r. Both sides r get cancelled, minus get cancelled. So we can get it is D is equal to 2 kilometers. D is equal to 2 kilometers we got. This is the final answer. It is 2017 one question. It is a 2018 Neet question. In this one, if the mass of the sun 10 times smaller and universal gravitational constant were 10 times larger in the magnitude. So the mass of the sun it is decreased, and one more it is the gravitational constant it is larger, it is increased. Which of the following is not correct? In this four statement, which of the following is not correct? See, raindrops will fast. Walking on the ground would become more difficult. Time period of the simple pendulum on the earth would decreases. G on the earth will not change. If you have the more knowledge about the gravitational chapter, simply we can identify while you are observing this option. This one it is the incorrect option. Fourth option, G on the earth will not change. Actually, G on the gravity on the earth will be place to place. It changes every time. But based on this given problem, will it change or not? We have to calculate. No need to think about these three options. We have to calculate this one first. He given mass of the sun is 10 times smaller than the, see here, if the mass of the sun is 10 times smaller, so ms divided by 10, mass of ms dash is nothing but a gs, gravity is nothing but a 10g. I have written, I am writing the formula, gravity on the earth is equal to g dash into me divided by r square. Here mass of the earth, g dash I am writing as a 10g. G dash, that is nothing but a 10g me divided by r square. If I write this one, Gme divided by r is equal to gravity on the surface of the earth, we know formula Gm divided by r square. Gm divided by r square. So this one we can write as a 10g. Gravity is increased now. See here. So, but in this problem what is given? G on the earth will not change. But here G on the earth it is nothing but a G is equal to 9.8. If I substitute here 10 into 9.8, that is equal to 98 meter per second square. Now gravity on the earth it is nothing but a 9.8. But here based on this given question, how much we got? It is 98 meter per second square. So the fourth option it is nothing but a wrong option. This is the correct one. According to these three are the correct. These three are correct. Fourth option is incorrect. Now 2019 problem. A body weighs 200 newtons on the surface of earth. How much will it weigh halfway down to the center of earth? See this problem. While you are going down to the depth of the earth, at that time what is the weight of the object? See here, while you are going to depth of the earth, what is the weight of the object will be? Decrease or increase? General question. Weight of the object will be decreases according to the formula, because while you are going to depth of the earth or while you are going to the height height from the surface of the earth, in both the cases gravity can be decreases. So gravity is decreasing means what about the weight of the object is decreases. We know formula it is G dash is equal to G into 1 minus D by R. This is the gravity equation. Otherwise G dash means you can write here gravity at a depth D. Gravity at depth D, GD is equal to G into 1 minus D by R. What is the D here? At what depth? In this problem they mention here weight of the weight halfway down. Halfway down means, for your understanding, this is the earth, center of the earth O, radius of the earth it is R. Halfway down means from A to B he travel. So this is half of the distance. Total distance is R. Half of the distance means what you can write? This is D is equal to, you can write R by 2. Total distance is, OA distance is the R. AB distance is nothing but a D. This D you mention as a halfway down. Halfway means half of the distance is equal to R by 2. Substitute in this equation, GD is equal to G into 1 minus R by 2 whole divided by R. R will get cancelled. You can write GD is equal to G into 1 minus 1 by 2. So you can get here 2 minus 1 by 2, it is nothing but a 1 by 2. 1 minus 1 by 2 is the 1 by 2 only. So G by 2. GD is equal to G by 2. But he is asking weight, not gravity. Weight means, what about the weight? Weight is equal to product of mass and gravity. So multiply this equation with the mass. So this is mgd and this is mg. Now you can write here weight at distance d is equal to, weight is equal to how much they given it is, weight of the object on the surface of the earth is equal to 200 newtons. So mg they given as a 200 divided by 2, so that is equal to 100 newtons. So whatever option it is, the fourth one, 100 newtons. Gravity at a depth d is equal to G into 1 minus d by r. In the problem they mention it is small d is equal to half a, that is r by 2. Just I substitute in this one, r get cancelled, I got like this, 1 minus 1 by 2 is the 1 by 2. But he is asking weight. So to get the weight, I multiply this equation with the mass, m into gd and m into g. So here mg divided by 2, mg is equal to, they given as a 200 divided by 2. 200 by 2 is nothing but 100 newtons.